In this example, we're looking at what's called the scalar resolute. Now, scalar means that it's not a vector. So that's the really important part here. Now, we know when we looked at vector resolute, we had a particular formula. So if we have, there's A and there's B, this question is looking at in the direction of B, so I'm setting it up this way. Now, previously, we were looking at a vector resolute. And the vector resolute of A in the direction of B was given by U, where U was A dot B on the top on B dot B, okay, and then times B. And that could also have been written as A dot B on magnitude of B squared B. So that's what the vector resolute was. Now the vector part, the I, J and K, if you notice what I've written there, this part here is a dot product. This is scalar. Oops. This part here, which is a magnitude and it's squared, that's also scalar. This part here is effectively what contributed the vector quality to the U. And if I write this out in a slightly different way as well, what you'll also see is that U can be written as A dot B on, I'm just going to keep one of those magnitudes of B underneath, and then move the other magnitude of B underneath B. And you may recognise now that this is A dot B over the magnitude of B, B unit vector. So B is a unit vector in the direction of B. So in particular, this form is the one that really makes it clear that everything vector is here. This part here is the scalar. And in particular, for the example that we're doing here, this is actually the scalar resolute, this formula here. So that's the formula we're going to use. Okay, so we're going to use, and I'll just put another line here, going to use that last formula. So use the vector, which is going to be our scalar resolute, equals A dot B over the magnitude of B. So whatever the indirection part is here for the scalar, that's the part that goes underneath. So we have A and we have B, so we do the dot product. A dot B equals coefficients of I multiplied together plus the coefficients of J, 2, and in this case actually there's no J on this side, so there's a 0 over here, and the coefficients of K multiplied together, -1 and 3. Will be -2 minus 3, which is -5. Magnitude of B is the square root of all the coefficients of I, J and K, all squared. And actually, it turned out a bit shorter than I needed it to be. The coefficient of I squared is 1, the coefficient of K squared is 9. So we've got 9 plus 1, which is the square root of 10. So therefore, our scalar resolute equals A dot B, which is -5, on the square root of 10. And you can see there with your answer that you don't have any vector quality to it. It's entirely a scalar. And if we wanted to simplify that too, multiply the top and the bottom here by root 10, okay, you'd end up with, and I'll just move this over a little bit, just so we can fit it in. You'll end up with -5 root 10 on 10, which is divide the top and the bottom by 5, which is going to be -root 10 over 2. So that's your scalar resolute. So the scalar resolute of A in the direction of B is -root 10 on 2. And it's not a vector, there's no I, J and K qualities there.